Okay, we're in section 3.11. We're talking about the hyperbolic functions, and here's how we define the 6 hyperbolic functions. I mentioned in the last video we are not doing trig. Don't get this confused with trig. Okay, h is not a constant. It's just a symbol to representing hyperbolic sine of x, for example, or hyperbolic cosine of x or something. All right. We talked about the derivatives of the hyperbolic functions, and so here they are. Make sure that you know those. And we looked at some examples of differentiating, and that's where we had left off. So I wanted to finish up this section here in this video. Let's find the inverse of y equals hyperbolic sine of x. Hyperbolic sine of x is defined as e to the x minus e to the negative x all over 2. Okay, and so I want to find the inverse of that. Well, inverse is all about switching x and y. So in this equation, I'm going to switch x and y. I'm going to have x equals e to the y minus e to the negative y all over 2. And I'm going to solve that for y. Okay, let's multiply both sides by 2. You're going to have 2x equal e to the y minus e to the negative y. That's the same as 1 over e to the y. And let me multiply both sides by e to the y. That way I get rid of this fraction here. So you got 2x e to the y equals e to the y squared minus 1. And let me subtract this term. We'll get all the terms onto one side. Now, it's kind of hidden here, but I would want to notice that I've got a quadratic. I've got a squared term, a linear term, and a constant equaling 0. If u is equal to e to the y, and I square both sides, u squared would be e to the y squared, so you're going to have u squared leading off, minus 2x e to the y, that's what we're calling u, so it'd be a minus 2xu, minus 1, that's all equal to 0. Okay. Now, I've got a quadratic. I'd want to use the quadratic formula here next, and so that's what I've got going on. The opposite of b is 2x plus or minus the square root of b squared. Negative 2x squared is 4x squared minus 4 times a is 1, times c is negative 1. So you're going to have a plus 4 there. And this is all over 2a. 2 times 1 is 2. When you simplify that, okay, 4 is in common to these two terms. You can factor that out. The square root of 4 is 2. You can then factor the 2 out from these two terms and cancel that one with the 2 down under. And that would leave you with x plus or minus the square root of x squared plus 1. Let's substitute back. U is e to the y, because I'm solving this for y. Okay, so e to the y is equal to x plus the square root of x squared plus 1. Now, why did I lose the plus minus there? Why did I just write plus? Well, it's because e to the y is never going to be a negative. X minus the square root of x squared plus 1 would produce a negative value, and e to the y never produces a negative since y is in the power. Okay, so I've just got the plus situation there considered. We're solving for y, so let's take the ln of both sides. The ln of e to the y would be y, and y would be equal to the ln of x plus the square root of x squared plus 1. Now, that's the inverse. So hyperbolic sine inverse of x is the ln of x plus the square root of x squared plus 1. And that would be the formula there for the inverse function. Now, what if we wanted to find the derivative of f of x equals hyperbolic sine inverse of x? Well, here's what hyperbolic sine inverse of x is in terms of a formula, okay? And so I'm differentiating a logarithm here. The derivative of the ln of an expression is 1 over the expression times the derivative of the expression. So I'm going to say 1 over x plus the square root of x squared plus 1 times the derivative of x plus the square root of x squared plus 1, derivative of x is 1, plus the derivative of the square root of x squared plus 1, that's a chain rule. You're going to bring down the power of 1/2, And so you're going to have 1/2 times x squared plus 1 to the negative 1/2 times the derivative of x squared plus 1, that'd be 2x. Or in radical form, you're going to have 2x divided by 2 times the square root of x squared plus 1. The 2's will cancel there. And I'm going to go ahead and get a single fraction in the numerator. Now, in the denominator, you can think of this as division by 1, because then when I flip the denominator, I've got the square root of x squared plus 1 plus x, which I'll cancel with the square root of x squared plus 1 plus x. And that'll leave me with 1 over the square root of x squared plus 1. Okay, so that would be, how I would get the formula for the derivative of the inverse of hyperbolic sine x. If I wanted to know how to get the formulas for the derivatives of the other inverse hyperbolic functions, I would have to do a similar thing that you see here. Okay, those formulas are in the book, and let's see here. It looks like they're on page 263. You can refer to those formulas if you'd like. These are not formulas that you have to have memorized. Okay, they will not come up a ton if at all, for other things down the road for things that you're doing here. So to me, they're just easy enough to look up in a book. There are applications of the hyperbolic functions, and your book has some kind of towards the end here of this section. I thought we would do problem 48, just as one application problem on page 265. So I've got that already open here. Problem 48, the Gateway Arch in St. Louis was designed by Eero Saarinen, I think is his name, and it was constructed using the equation that you see here. Okay, we're using the hyperbolic cosine function. And this is for the central curve of the arch, where x and y are measured in meters, and the absolute value of x is less than or equal to 91.2. Okay, part A, we're going to graph the central curve. Now, they intend for part A to be a calculator problem. They've got the calculator screen there. So I'm going to go to the calculator, and I'm going to type in this equation here into y1. So let me do that now. If I go to y equals, then in y1, we've got 211.49 minus 20.96 times, okay, to get the hyperbolic cosine function to appear, you're going to hit second 0 to go to the catalog. In the 83, 84 models, it'll be similar in the 89 model, okay, and the Inspire model also. And you're just going to scroll down to where you see the hyperbolic cosine function there, all right? And I'm going to hit enter. It brings me back to the y equals screen, and okay, it's hyperbolic cosine of 0.03291765x. Okay, and then I can hit graph. For this problem, the best viewing rectangle is to have x going from negative 100 to 100. That's because of the conditions on x that were told in the problem. Okay, the absolute value of x being less than or equal to 91.2 means that x is between negative 91.2 and positive 91.2. So all of that going from negative 100 to 100, and then let's have y go 0 to 200. I'll go ahead and make sure I'm in that window setting here, and I'm definitely not. So, okay, negative 100 to 100 for x, and then for y, we're going from 0 to 200. Okay, and then I can hit graph. So I get some curve here that kind of resembles what you would see with the St. Louis Arch. Okay, and I've I've drawn that curve, and that's all they're looking for there in part A. Okay, now in part B, it says, what is the height of the arch at its center? Well, this curve is symmetric about x equals 0. So to find the height at the center, I could just plug 0 into the function. Hyperbolic cosine of 0 is what? Well, I shouldn't need to run to a calculator for that, because hyperbolic cosine of x is e to the x plus e to the negative x all over 2. If x is 0, e to the 0 is 1. 1 plus 1 is 2. 2 divided by 2 is 1. Okay, so hyperbolic cosine of 0 is 1. So all I have to do here is I need to take 211.49 minus 20.96, and I get 190.53 meters. So that's going to be the spot where the arch is at its highest there at the peak. Okay. Part C, it says, at what points is the height 100 meters? Okay, well, y represents the height, okay, in meters. So I would just simply set y to be equal to 100 here, and I would have to solve this equation for x. Let me subtract 211.49 from both sides, and then divide by negative 20.96. Okay, and I've miswritten this part here. It's supposed to be hyperbolic cosine of 0.03291765x. Okay, sorry about that. Equals 111.49 divided by 20.96. Okay, so I'm going to take hyperbolic cosine inverse of both sides. That way I would just have what's left over on the inside. Again, it's not, I didn't write this correctly. It's supposed to be hyperbolic cosine of 0.03291765x. Okay, not just hyperbolic cosine of x. So I'm taking hyperbolic cosine inverse of both sides. That'll leave me with 0.03291765x on the left equals hyperbolic cosine inverse of 111.49 divided by 20.96 on the right. Okay, and you would then divide by 0.032911765 to have x all alone on the left. Let's go to the calculator, okay, and we can type in, let's see here, hyperbolic cosine inverse. So I'd have to go back to the catalog, and I'd just scroll down to where I see that function. Here it is, and of course make sure you don't get cosine inverse, right? We don't want that. Hyperbolic cosine inverse of, what was it, 111.49 divided by 20.96, enter. Okay, and then divided by 0.03291765, enter. Okay, and I'm getting 71.56 if we go nearest 2 digits on that. Okay, and of course I don't need to make sure I'm in radian mode or degree mode or anything like that, right? I'm not doing any trig. If x is roughly 71.56 meters away from the center, and then you come up to the arch, you're going to be at a height of 100 meters. Also, by the symmetry of the arch here, if you go 71.56 meters to the left of the center, okay, you're also going to be at a height of 100 meters. So I'd want to state these 2 points then as my answer. Okay, part D. What is the slope of the arch at these points in part C? Okay, so slope means I got to do something with the derivative, right? I need to know y prime. Here's y. Derivative of a constant is always 0. And so you're going to have negative 20.96 times, here'd be a chain rule, it's going to be hyperbolic sine of 0.03291765x times the derivative of 0.03291765x is 0.03291765. Okay, and if you multiply these two numbers here, here's the next line that I'm getting, okay, and x is 71.56, right? I'd like to know the slope of the graph at that value, and so I would just simply plug that number then into the derivative. Well, I can use my calculator here and type that in, so it's going to be negative 0.689953,944 times hyperbolic sine. I'll have to go to the catalog there, and you'll have to scroll either up or down to get to the S's. Okay, and here's hyperbolic sine. We'll hit enter. Of right here, it's 0.039. 0.03291765 x. X is 71.56 though. Okay, so times 71.56, enter. I get negative 3.6. Okay, and of course using some symmetry here, if I were to plug in negative 71.56, I would get 3.6. Okay, just be opposites here, right? Using the symmetry of the arch and those two tangent lines being opposite slopes. Okay, there's some other applications mixed in for the hyperbolic functions, and you can look at those. Just kind of the big thing here is that, you know, I would like you to know the definitions of the hyperbolic functions, and then also make sure that you know the derivatives. Okay, those will come up here and there, but again, they don't beat you up with it. Okay, but it is still worth knowing. Okay, and here's the homework on page 264. Be sure to look at the odd number problems that I've got listed there. At this point, we are now done with chapter 3, and we'll plan to get into chapter 4 coming up now.